Folks, Mr. Norman here. We're on to functions part D, part dos, part 2, part couple, part pair, part I am out of things. Trio -1. So I'm going to work an example or two of each of the sections, but first we have to cover some vocabulary. So what do we add here? So we have X and Y. We're going to use this thing called Dixie. Dixie. Rhodey. So all of these words are going to go with the X. So we have, one second. Sorry about that. We have Dixie, Rhodey. So Dixie, we learned last part that X is the domain. So here we're going to say that X is the independent variable. Dixie, Rhodey. So we have D, domain, I, input, X, independent. So this is all this stuff is what X means or goes with X. When we see any of these words, we know to think X. So domain, we know is the set of all X values. Input, I'm going to explain inside of the first question. And independent, it goes back to input and output, but here's an example. If we have a graph, let me change the color. If I have a graph, on the bottom, I'm going to have time, and on the side, I'm going to have pay. Most of us know. A lot of people work by the hour, right? Most people work by the hour. So as I get more time, my pay is going to increase. Right? But is everyone paid the same? No, not everyone's paid the same. You know that. But what's the average work week? 40 hours, right? So the number of hours you work, 40 hours. Let's say 40 hours. Does not tell you how much you're going to get paid because most people work 40 hours. But we know the less hours you work, the less pay you're going to get. So pay is dependent on time, but time doesn't necessarily change, is not dependent. And what's another way of saying not dependent? Independent. So pay depends on time. Time is not dependent or independent of pay. The more pay I get, the more I work, the more pay I get. But everyone works about the same number of hours. If we work the same number of hours, does that tell us we're going to get paid? No. Time is independent of pay. Another way to think about it is studying in grades. The longer you study, the more likely your grade's going to be higher. But does grade equal time? No. So we have independent, dependent. We already know domain and range. Now we're going to talk about input and output. So what we have here is called function notation. It's function notation. You read this as g of x equals this, g of x. That's how you read this. That simply means that x is input. You're going to input x in those parentheses. You're going to input x in those formulas. The output is y. So I'm going to work an example to demonstrate. We're going to work number 4. We're going to input our -3 into our function. How to read this? F of x. Everywhere we see an x, we're going to put parentheses. Let me get this color coordinated. Cubed plus 4x squared. So we're going to input this. So what do we input? -3. That's what it says here. So I'm going to go to an online graphing calculator. I believe Desmos is the calculator I have inside of the Classstream. If I don't have a calculator in the Classstream, please let me know. Okay. So here's an important note. Notice how this says -2 squared is -4. What's a negative times a negative? It's a positive. We have a negative times a negative. Negative times a negative. How come this says -2 squared is -4, but when we square it, -2 times -2, we get +4? That's because this is the way our calculator reads the top one. This is what we want it to read. Always make sure that you're putting whatever number you're squaring inside of parentheses. That's why for our set, that's why when we set up our equation to evaluate the function, we replace our x's with parentheses so we don't mess that part up. So we have -3 squared. No, sorry, -3 cubed, or to the third power, that equals -27. Plus 4 times -3 cubed. No, 4 times -3 squared. 6. So we have -27 plus 36. That gives us 9. But wait a minute. Should this be purple? Well, let's see. We have f of -3 equals 9. And we know -3 is our input. So what does 9 have to be? Our output. We input, our input was 3. And our output is 9. So that means whatever is inside of the parenthesis next to the f in our function notation, that's our input, that's our x. And whatever we get after we evaluate is our output, or our y, which transitions us nicely to this next set. Given each function value, write a corresponding ordered pair. Well, we know this is function notation. And if it's function notation, that means this is input, or x, and this is output, or y, which means for this one, our ordered pair will be -10, comma, 1. And don't worry, I'm just doing this to keep the color thing. So this is the answer to 14. And just to clarify, the answer to 4 was 9. The next section, does this describe a function? I will actually come back to part 15. It's going to be its own video. Sorry, I should have told you that sooner. So complete the ordered. Oh no. I have a typo. These all should say pair. Okay. So we're going to read this function. Remember, the first one is x. The second one is y. This is a function. Does it pass a vertical line test? What's a vertical line test? This is how we tell if a graph is a function. If it does not cross, if we draw a bunch of vertical lines and they do not cross the graph more than once, it is a function. So, complete the ordered pair for f. So simply we're going to look, this is x is 0. So when x is 0, what is our y? So here's x is 0 with the origin. We're just going to go down. What is y? We went down 1. So y is -1. It's that simple. It's that easy. We'll do the same for the next one. Here, we're doing a very similar thing. So what is this? This is our input. And it equals our output. So if we input 0 for our x, what is our output? Our y, which is -1. So it equals -1. So now this one says something a little different. This says if f of x equals 0, find the values of x. So we got a hint, right? It's telling us that we're looking for x. Well, we already know that this is our output, which means this is our y. So when y is 0, what is x? So we're going to go where y is 0. That's here. We're going to look at this line. Earlier, I dropped down. Now I'm going to look across because this is y. So we actually touch our graph at 2 points. So when y is 0, we actually find x here. X is -2, and x is 5. All right, Cal folks, that's the end of this video. Remember, I'm going to have a follow-up video that goes over 15 through 20. In the meantime, make sure you attempt what you can on this packet and get ready for the next one. Cal folks out. Peace.